So we have block A, which weighs 3 kgs, and block B, which weighs 4 kgs. They're in an elevator with A on top of B. So for the force diagrams, we'll first show the forces on block A. So this dot that I'm drawing represents block A. Pushing up on block A is block B. So we have block B on A. So that there's another force, and that is the force pushing down on it. Well, in this case, pulling it down, because there's gravity. So gravity will be pulling down on A. Now we will do the force diagram for block B. So, going up on block B will be the elevator, since the elevator floor is pushing up and holding up block B. Pushing down on block B and also pulling will be block A, represented here with A on B. And then our second force that will be on block B is gravity. Part B asks us to find the acceleration of the elevator. In part A, it stated that the elevator is pushing up on block B with 105 Newton force. So to do this, we're going to set up the equation F net equals ma. M meaning mass and A standing for acceleration. F net meaning the combined forces from everything. To find the force of A and B that it's pushing down on the elevator, we need to take into the account that it weighs 4 kgs and 3 kgs. 3 plus 4 is 7. You multiply that by negative 10 because negative 10 is the acceleration of gravity. So doing that, 7 times negative 10 is 70. So we can put that into our equation along with the 150 newtons that is pushing up on the elevator. So 150 minus 70 equals ma. We can now fill in for the mass, since we have the mass and we are looking for the acceleration. So like I said, the mass of A plus B is 7. So 150 minus 70 equals 7A. 7 goes for the mass, and A is what we're looking for. So, now what we do, we can simplify this. 35 equals 7A. Okay? Then we're going to divide by 7, and then we figure out A equals 5 meters per second squared.
To find how big the force down on block B from block A is, we're going to be looking at this force diagram. We have the force of gravity on block B, and we also have how much is being pushed up by the elevator on block B. What we need to find is right here, the force of A on B. So far, for this force diagram, we have 105 minus A on B plus 40. The 105 right here is from the force of the elevator on B, and the force of gravity, or the earth pulling down on B, is 40 because, as we already know, B is 4 kilograms, which equals 40 newtons. Before we find the force of A on B, we need to find the net force of block B, which is going to be F net equals ma. The mass of block B is 4, and the acceleration is 5. Therefore, our F net is 20. So, from this, we find that 20 equals 105 minus the force of A on B plus 40. Now, from here it's simple math. 105 minus 40 is going to be 65. You subtract that from 20, you get negative 45 equals negative A over B. So the force of A on B will equal 45 newtons. A non-physics definition of the word force as a noun could be strength or energy as an attribute of physical movement or an action. Here are some examples of non-physics forces.
In contrasting the definition of force as a physics term and the definition of force as a non-physics term, you could take, for example, military force. You would not use the physics definition of force, which is force is a quantitative description of the interaction between two physical bodies, such as an object and its environment. Force is proportional to acceleration. Obviously, you would not use that to define a military force, which is defined as a unit that is part of some military service. While you would not use the physics definition of force to describe a military force, you can compare the two, force in the physics sense and military force in the non-physics sense, by saying that they are both pushing on each other in some way. Military force, it's all about strength, and physics force, in some way, is about strength as well.
A force to be reckoned with. Someone is so big that you don't want to mess with them. They are a force. A military force. Jake Granji. Such a force. Fargo force. Hockey team. Very forceful. Mental force, as opposed to physical force or physics force, making someone do something.
Comparing the non-physics force examples to an actual physics definition, let's first get the physics definition. So force is a quantitative description of the interaction between two physical bodies, such as an object and its environment. Force is proportional to acceleration. So, example, when we're talking about military force, this could be, for instance, interaction between two armies at a time of battle when they come and start to fight each other. And then when we're speaking about the Fargo force, which is a USHL hockey team, when they play another USHL hockey team, those are two forces that are interacting with each other and going at it. Now to contrast the two, when we talk about military force, we go back to the example of the two armies meeting up to each other to show the force. But in the definition, it states that force is proportional to acceleration. So just because one army is moving faster, something doesn't necessarily mean they have a bigger force.